The windmill is one of the simplest ways to gather energy from the wind. Wind occurs when there is an imbalance of pressure between two places. Much like water, wind will move at fast speeds to equalize these pressures. The kinetic energy of the wind can be captured by placing turbines in the wind's path. Windmills are constructed by attaching a wind turbine to a long pole or structure. These turbines capture energy from the wind by turning when force from the wind is exerted on the blades. These blades spin, which in turn rotates a generator which creates electricity. By placing the turbines higher up where more wind is present, they are able to capture more energy. Because wind is a naturally occurring phenomenon, as long as there is air, it is a resource that will never run out. Also, no harm is done to the earth at all in the process of capturing this wind. These are some great benefits which we will explore.
Now, let's see what real wind power plant looks like.
2012 April 27th, and now it's 4:35 in the afternoon, and here we're in the back of Loomis, and we got this awesome wind kit from Professor Pitts, and we're trying to get some wind, see how it can be generated into electricity. Look, the LEDs light up, so that means we got good energy from the wind, and now you hear the buzzer. This time it got really clear with no fuzzy sound, and it's pretty clear, and I don't know what that song is, but we heard this many times. Hey guys, so now we got back indoor, and now we're using this fan to simulate the wind outside. As you see, as the fans turn on, our wind turbine starts to spinning faster and faster, and now you see the voltage is building up, and so end up to be around 1.9 volts. And now, yeah, we got a kind of steady reading now. And Brandon, could you please turn the fan a little bit faster? And now we are having a faster speed of wind, and now the voltage goes up roughly about 1.96. And what happens if it goes even faster? So now we got the reading goes all the way up to about 2 volt, right? And now, so this is almost the same as the voltage we read yesterday from the wind outside. So the fan is a really good simulation.
Here we can show the comparison to the voltage created from the windmill compared to a double-A battery. Here we have 1.62 volts.
Hey, so can you show the voltmeter of this, or yeah? Zoom in. So now our reading is roughly about 0.28 voltmeter, and it's negative because it's spinning backward. Okay, so what we did just now is we make a different angle with respect to this vertical plane. So now, before it was just around 45 degrees, and now it's being reduced, and we see that now the blade is rotating faster, and so the power is still not as big as the ones with less blade, but we do get a bigger reading of voltage, which is roughly about 0.6 volts magnitude. So yeah.
In the demos just performed, we learned that wind can produce a very good amount of energy, in which we showed that a simple wind turbine can produce more than the power of a AA battery. However, it also showed that wind energy is very conditional, in that only when there is wind can the energy be generated. Our demo also demonstrates that faster wind produces greater power, and the shape of the blades will affect the efficiency of the wind turbine. Now, let's look at the real wind power plant.
Wind energy has been in use since the 7th century and is becoming a larger part of our energy today. In the U.S., wind energy accounts for approximately 3% of electricity. Today's modern turbines come in two different forms. Firstly is the more commonly seen horizontal axis wind turbine, which can range from 200 to 300 feet tall. Less common is a vertical axis wind turbine, which, as its name suggests, rotates on a vertical axis. Each design has slight disadvantages and advantages regarding power created and useful locations. Many wind turbines are often grouped together to form what are called wind farms. These farms often cover dozens or hundreds of acres and are able to produce a large amount of energy. Roscoe Wind Farm is the largest such, boasting a total of 627 turbines. Wind farms are also built offshore. commonly seen in many European countries. This has its disadvantages with construction and maintenance, but typically creates more energy due to stronger and more consistent winds. A graph here can be seen which shows the potential for wind energy for the United States.
Wind energy is obviously one of the future energies, as people are now looking for cleaner alternative energy. Wind energy will be more exploited in the future. Offshore wind farms allow vast of wind energy to be used for human. In fact, Britain and Germany are installing new wind farms, and the United States is improving its offshore wind technology by 2014. The total offshore wind power is expected to reach 75 gigawatts worldwide by 2020. Engineers have also built the prototype of flying wind turbine, which could be used for the model of future air-based wind power plant. The future of wind energy is very bright. We should start to generate our future.